Hi, everybody. I'm still Ms. Lee. We're going to go ahead and talk about two last properties. These two properties are called the inverse properties. So, as you know, logs are the inverses of exponential functions. So, if two functions are inverses of each other, then they will basically cancel each other out. So, if you have, for example, log base b of, and then b to the x, an exponential function, what happens is that log base b of b to the x becomes just x. And if you think about that by the power property, this also makes sense because if you do the power property here, you would move the x into the coefficient. And so you would have x log base b of b. And log base b of b is just 1. And that's an identity property, or just thinking about it, b to what power is b? Well, that's just 1. So you have x times 1, which is just x. And so that's our first inverse property. Log base b of b to the x equals x. Our second inverse property is taking it the other way. So if you do b to the power of log base b of x, that just equals x. And same thing, you can justify this by rewriting this in log form. If you rewrite this in log form, you'll end up with log base b of x equals log base b of x. So this is another inverse property. Okay, and so if you think about that, it's like you have the exponential function and then you have the log function. So they kind of cancel each other out. It's that type of idea. Okay, so let's go ahead and try an example with this. So we have 49 to the power of log base 7 of 5. So if you're looking at this, it kind of looks like this b to the log base b of x, but it doesn't quite match it, right? There's a 49 here, but there's a 7 there. But what you want is for those to be the same number. So if you want them to be the same number, let's manipulate it to make it the same number. So we're going to go ahead and rewrite it with the same base. So you'll notice that that's often a strategy, rewriting with the same base. Well, this base is 7. This is 49. I know how to write 49 as a base of 7. So I'm going to rewrite 49 as a base of 7. So that will be 7 squared. So 7 squared has a base of 7. So you have 7 squared all to the power of log base 7 of 5. Well, what do you do with exponents when you have 7 to a power of something and then all to the power of something? What do you do with those two exponents? Well, you multiply them. So we're going to simplify a little. So you have 7 to the power of 2 log base 7 of 5. So again, it still doesn't quite look like this because there's a 2 in front of the log. So if you have a coefficient in front of the log, does that ring any bells of what property to use? So coefficient of a log means power of the argument. So we will go ahead and rewrite that as the power of the argument. That 2 is going to be the power of 5. That is the power property. So 7 to the power of log base 7 of 5 squared. Well, 5 squared is just 25, so we can simplify that. So we have 7 to the log base 7 of 25. But what you'll notice is that the bases are now the same. This 7 is this 7. And this lines up exactly perfectly with this inverse property over here, that if you have b to the log base b of something, then it's just that something. So what is this going to equal? Well, it's going to equal 25. And there you have it. Those are the inverse properties. Happy day.